Hello and welcome to the channel. So we've got a Fender Bassman 410 inch speakers in this one. These need no introduction. This is a reissue, though it's not an original one, obviously. This is from early to late 2000s, I think, and it's in because one of the tubes is not functioning correctly, one of the output tubes, according to the customer. So let's get the back off it and have a nosy. Right, got the back off it. You see we've got one groove tube down there looking a bit baked. So let's do some testing. So it's, I've got it plugged into the current limiter, just got a 100-watt bulb on it, so we're not going too mad. Plug it in, it always works better. There we go. Bulb's dim. And let's just see what we've got. So that's the plate. You can't see this meter up here, and you just about get that in shot. Let's just raise the camera a shade more. So pin 3 on this tube, we've got 314 volts. Pin 3 on that tube. Oh, that's gone up 321. That's just the current limiter. Then we've got a screen here, and we've got 324 volts. Let's try this screen. Negative 34 on that screen. That's definitely, oh, negative 34. So there's something not right there straight away. And the one in between there, that's also the but. So we've got the bias on pin 4 and pin 5. Now what's going on there? Just check this tube again. Yeah, 330, and if we go into there, we should have the bias. Yes, we did. Right, so there's the problem. Anyway, this tube, well, the tubes will. This tube's lukewarm, but then obviously remember we've got the current limiter on. This tube's stone cold. So let's just take that. Let's just take this tube out. Just try to hold a light in there. The filaments are lit, or they were lit when I took it out. Just saw them go out as I pulled it. So let's get the tube out. And we'll just going to check again now with the tube out. And now there's nothing on there. And our negative 35. And there's nothing on there. So we've got no screen voltage on that tube. So yes, that's the problem. No screen voltage. So that means we've got to go to the screen resistors on there. Screen resistors R32 and R33, and they both look a bit baked. Let's try this one first. That one's got an additional bit of baking on it. Well, there's nothing from him, and we've got something from him. So he's 482. I think these are 470s, but he's open, and that's the problem. Obviously it's the problem. If there's no screen voltage, it's usually the screen resistor. So we need some new screen resistors. Now this amp has got these IC caps in, and this amp is probably from around that era where they had the bad batch. Now if this was a pretty new amp, then I wouldn't be changing these, because I think these are made by Cornell Dubilier now. They've got a bad name because of that bad batch that they did, but obviously this is from that era, so they've obviously been in there 20 years anyway, so they've survived okay. So we'll have those out because obviously we're going to have to take this board out to change that resistor. Right, we've got the doghouse open there, and we're just going to change these caps. So we've got a couple of 47s and a couple of 100s which have just been delivered. Right, I've got the caps in there, and you can see we've soldered them up. Just coming a bit closer. You can see they've soldered them up, cleaned all the flux off, and it looks like we've never been there, and that's how they need to be. So we'll get that bolted down, get the top on, and that's one job out of the way. Right, so I've had a bit of a think about this amp, and something I can remember from the past when I did the last one of these. Something in the back of my mind. Before I take this board out, I'm going to snip off those screen resistors, tack the 1Ks in, and I'm going to change this amp to 240 volts if it's not been done already. And then I'm going to check the bias on this amp and make sure that the bias preset pot will set the bias correctly before it reaches the stop. I seem to remember something about that last time, and this amp was biased cold. If that would be the case, I've got to take this board out again and adjust the resistors, so I'd rather get this right first time. So let's just have a look at this. This is what I've downloaded and printed out. So this, and I've just blown this up, this is the wiring diagram, and you can see we've got 100 volts, 230 and 240. So if you look on 240 and 230, CP6, CP5 for both, CP28 for both, 29 for both, CP30 same for both. But then we've got S1B and CP2 and S1B. You can see that CP2 is 240 volts and S1B, and that is, of course, the CP2 is the black and white wire, will be on CP2 if it's 240 volts, and the black wire will be on the switch S1B, and vice versa if it's 230 volts. So if this is wired 230, we should expect to see the black wire on CP2. If it's wired 240, we'll see the black and white wire on CP2. So let's look for CP2 in here. CP2 legging round in there. It's hiding. Well, there's the black and white wire. Well, that's going on to the switch. Black and white S1B, so that it is wired for 230. So CP2 then, in that case, should have the black wire on it. So where's, and there it is, there it is. Why did I not spot that before? I think we're going to have to take this tie wrap off. In fact, I know we are. So if you've got one of these Bassmans and you've never changed this over, then we'll just go through this. Right, so we're in now having a look. So here's CP2. You can see him hiding under there. CP2, and he's got the black wire on. So if we come to here, and we can see CP2 black. So 230 volts, and if we look at S1B, that's black and white, and if we look on the switch, that's here That's black and white. So we've got to swap those two wires over. Pull black and white off there because the camera's right over it and I just couldn't get it off without, so I've pulled that off. So now we've got to, all we've got to do is swap this wire. It goes on CP2 and then the black wire goes on the switch, and that's 240. Be careful what you're doing in here though when you're changing it over, because you've got another black wire here on CP1. You want to make a mistake and pull that one off and put that on the switch. It must be CP2 here, and you'll find if CP2 on this first row of spade connectors is the last one near the tube sockets. Right, I've got this all set up and ready. We've got 1 volt, this meter measuring the plate volts, this one's measuring the drop across one side of these tubes. These are test tubes. I'm not putting the customer's tubes in this amp yet because we're not 100% sure that there isn't still a fault on this amp anywhere that blew that screen resistor. We presume it's the tubes, but presume's not good enough when we're putting a brand new set of tubes in an amp. We don't want to be popping those, so we're going to use this test set, and I'm obviously not going to put the original tubes back in there because we suspect that blew one of the resistors, so we're not going to risk that. I've got a 100 watt bulb in the current limiter, and off we go. Just waiting for the rectifier tube to warm up, and that's coming up now. Here we go. The amp's fired up. Speaker's a bit of a distance away from the microphone, so you might not hear. Right, I'm just going to stick another bulb in, so we've got 200. There we go. And that should hear the plate voltage. See the plate voltage come up, and hear the amp now should be able to hear it a bit more. It's a bit of frying. Not sure where that's coming from. I have cleaned these sockets. Right, that appears to be running okay. Let's just flick it off the limiter. And you can see this amp's biased quite cold. I'm just going to go into the preset. Now the preset is turned flat out, so let's go the other way. Have a look. So you can see now we've only got 0.5 on there, which is way low, and if we turn the preset up, flat out, we've only got 1 volt on there, so that's telling me that this amp is biased in, really cool. Now the reason for that is because we've gone up to 240, which has reduced the bias, so that reduced the dissipation. The tubes, we've got less plate voltage. We've also swapped those resistors from 470 ohms to 1k, but I wouldn't have thought that's made a massive difference. And if we just test the plate, the screens on here with this meter, I've got 433. I'll use the same meter for the plate. We've got 436, so it's only a couple of volts difference there, just a couple of volts, so it will have made a slight difference, but not a massive difference on there. So roughly about 48 ohms is the winding on these transformers. I've actually measured this side, not the side we're actually measuring on here, but it'll be close enough for this. So 48, sorry, wrong way around. So 1 volt on there divided by 48 is 20.8 milliamps. If we times that by the 436, 9 watts. So as I suspected, that there's not enough travel on that pot to bias the tubes. I'm going to switch this off, let it cool down, and we're going to put the new tubes in. We know now that there's no fault on this amp. We've diagnosed it. It was obviously the tubes that caused the problem. So we're going to put the customer's new tubes in, start on the current limiter, and then we're going to see what we can get out of those. So that fry must be a preamp tube or something on the preamps, because now we've changed these output tubes. We've still got that bit of frying. Yeah, so that's probably a preamp tube then. Let's just go back on the current limiter. Let's just stick this Mullard tube in here, in this preamp. V1 I would imagine it is. Just come down. I've just swapped this tube here. Let's see if we can get rid of that noise. Oh dear, the battery's gone on that meter. Now that noise is the lights, and that's suddenly gone much quieter. Let's just, yeah, just screen that with my hand. Well, that seems to have sorted that out. So I've just took my hand away now. That's why I'll just show you what I'm doing there. So that's just the lights that are doing that, and I'm screening those now. Here's the one we've just removed, which is a Softec, and things seem to be running much nicer with that in. That's just a Mullard tube I've dropped in there. So that's another fault diagnosed, albeit a minor one. So that tube is kaput. Right, so the batteries have run out in the meter up top there, and there's only 16% left in the camera battery. So what I'm going to do now is go off, have a bit of dinner, charge the meter up, charge the camera up, although I have got 2 more batteries for it, and then we're going to come back and see what the bias is on these tubes and where we are on the scale of this bias pot. Right, we've had dinner and we're back. We've charged up the meter, and we've got the new tubes in, and we're just going to switch on again. So we've got the current limiter on. And off we jolly well go. So let's have a look at our voltages then. So we've got 355 plate volts at the moment, but we're still on the current limiter. So let's go off the current limiter now. We've got rid of our frying. because we've got the Mullard in there. He seems a bit microphonic. We shall be changing him for something else, but so we've got a little more current now, but yes, still nowhere near enough there, I can tell you. Nowhere near enough. And I took some readings before I switched the camera on. So the right side is 45 ohms. We've got 26.6 milliamps on these tubes, which is an improvement, but obviously still not enough. Times 435, and we've now got 11.6 watts, which is quite a bit under there. So we need to change a resistor in the bias circuit, and that I think is R41. And this is why I'm doing this before I get this board out and do the work on the amp, because if I'd have just done those 3 capacitors, put the 2 screen resistors in, put this board back in, and then we can only get 11 watts of bias on the tubes. Remember, these tubes should be biased at 70%, is 21 watts. The 606 GCs, and these new Bassman reissues, well, I say new, it's 2008 this was made, I think, because there was a date in the under the doghouse on that PC board, said 2008, but obviously they're different to the original Bassmans, and the original Bassmans had 5881s. This one's got 606 GCs. Got quite a low plate voltage though on this, really, 438. I would have thought we'd see a bit more than that with it biased that low, but maybe somewhere around about 450, 460. But so yes, we've got to get that bias up. I've cut out R41, and we're going to jumper in resistors till we get this bias in a window. Now, I'm not using the new tubes for this, that would be foolish, while we've got this jumpered in. And these tubes gave us 9 watts. The new tubes gave us 11. So I can put it in a window with these, no trouble. I'm not risking those new tubes while we're playing around in here. I've got it on standby, and I've checked to see if we've got bias volts before we switch on the standby, because we can test whether we've got bias volts in standby. So we know the resistor's connected, it's jumpered in and it's connecting. So if we flick on, we're still on the current limiter. So we've got 2 volts on there now. Let's just go down with this. And that drops as low as 1.4. So we're getting nearer. 2.1 divided by 45. Now we're up to 46 milliamps times 429. That's 20 watts. So we're still on the stop, but that's 20 watts now. So if we put the new tubes in, we can put a couple of watts on that, so that'd be 22, so we'd be a bit over. Right, jumping in a 27k. Just going to check that we've got bias volts. I've got it on standby before we start. Now I've got negative 42, 43 now. So let's just put the current limiter on just to make sure we're, and you can see we've got 1.2 volts now already on the current limiter. So we'll come off the current limiter, and the tube's now going up. Conductance is going up. Down to 410 volts. I think one of those tubes is a bit tired. It took a while to get up there. We're now up to 55 milliamps now, times 420. Now that's 23.1. So now they're over 70%, which will make the others 25. So we need to come down on the trim pot. And now we're down to 2 on there. Now we're down to 44 milliamps times 428. Now we're down to 19. And but remember, our new tubes have got a couple of watts on these, so that would be 21. So that will probably just about get this halfway. So what's the coolest point now? 1.5. is 33 milliamps times 440 is 14.6, which would be 16.6 on the other tubes. So that is perfect, and that will probably just center out nicely with those tubes in that trim pot. That's spot on. So if you're working on your Bassman and you've changed the voltage over to 240, remember this only applies in the UK because we're on 240 volts, or maybe if you're in Australia, I think they're on 240 volts if I remember. Then if you and you really should be on the correct voltage, because, and the reason is you know, people are saying, well, it's, you know, does it make any difference? It's just plate voltage versus the tubes were biased okay at 230. Well, it's the filament voltages, which is why you should change it, because you're running these filaments at 7 volts and it's too much. They need, so that's why we've changed it for the filaments. Really, this I mean, as it on the Blues Juniors, they're already biased at 100% when they come out of the factory, so running them at 230 instead of 240, as we've all seen in the previous videos, is just adding insult to injury. But in this case, this amp has been biased at 70% at 230 volts, but because it comes into this country and we're overvolting the filaments, not by much, but you know, 5% is over or under is ideal on these tubes. Anything over that, you can go to 10%, yeah, but you're better off staying within 5%. Once it goes to 7 volts and 7.1, and the problem is, as we've seen on our meter here, we can get up to 243 volts on here. So then 13 volts over, these tubes, then the filaments are getting too much voltage, so that's not good. So we've got a 27k resistor in there. We've gone from a 36 to a 27. We'll tattle down and we'll let it cool down. I'm not going to put the new tubes in because, as I said, we've got this jumpered in. We know roughly where we are with that. That's fine. So, and I've got, although I've got the 27k here, but I've also found a half watt one to go in there because the resistors are quite small. They're only quarter and half watts or whatever, half watts, I don't know, a lot of them. Right, so get all these probes and things off, wait for it to cool down, remove all the tubes, and then we're ready to start getting the board out and going for it. And you can see I've already got some of the stuff off here. It shouldn't be too long to get this board out, hopefully. Now, another thing that I'm going to do on this one, I'm going to cut these caps off before I take the board out. Just cut the terminals and get them out while they're in here. And the reason for that is that when I lift this board, these wires here, every time we turn that board up, these wires are going to be getting weaker and weaker, and it'll be starting to break off, and then I'm trying to get these off and tugging and doing on there because they're glued down, and then up it comes again to get the wires out, the pins out from the thing, and then we clean the board, up it comes again to have the new caps put and so on. So while it's down, it's one less flexing on these wires, I figure, to get while I get these out. Got all the components in that we needed to get in. That means my mobile phone must be somewhere around. It is. We need to remove that. That's coming through, confusing things. So I'll go through what I've actually changed on this amp then, and then I'm going to just go through a bit how I took this board out. I've changed these two capacitors. Now you can see that there's a space missing here if you look. The reason for that is these two capacitors are wired in parallel. 222s wired in parallel make 44. So it seemed a bit of a waste to put two 500 volt 22 microfarad caps in there, and instead I just put 147 in there, which is 3 microfarads over if you do the maths roughly. So it's the same. So I've just put that in, and that's fine. Just run the solder over the hole on that just to keep the trace strong. So if you do that, you don't have to, and the trace is quite thick round the hole, but I just run the solder over the hole, so it just makes the trace a bit stronger. But that is a much better way of doing that. Don't know why they've done that, but the amp's on. It's running on a 60-watt bulb, working fine. It's quiet. Change the 220 microfarad cathode bypass capacitor there. And I've changed you probably can't get in to see those, just lean over a bit, you might be able to, but there's a couple of capacitors here and they're on the bias. I've changed those, in fact there's 3 there and they're all on the bias, so that they've been changed, and that's all the caps that's in this amp, because of course the others are in the doghouse. We've already changed those. There's our 2 resistors now, 1k resistors, you might be able to see those. Screen resistors, and I've raised those off the board. And the only other resistor I've changed was that 27k. I think we had 39 in there before to balance the bias on this amp. Now only one wire broke off, which was this wire here, which is a ground to this board, broke off, so I've just soldered that on. Well, so far I've checked round, I can't see any more that's come off. The amp is running. Now getting this board out, I've still got the pilot light disconnected here, and I've pulled the shrink tubing over that so we don't get any shorts on there, and we're going to redo that. Now the reason I did that is it's easier than trying to get that nut off in the side there. That's just a nightmare. So what I did is took all the bolts out, well, took all these leads off that I needed to take off, and I didn't take all of them off, so I took off CP32, which is here. So I took off CP32. We've got 3 wires coming here from the doghouse, which are CP33, black from the doghouse, 3 CP31, and orange from the doghouse, CP34. So they came off. CP25 and 24 are the choke, and that's these wires here under that jumper there. They came off. The center tap is CP23, which is this one here. So that had to come off. And then the 2 standby switch cables, CP22 and 21, also came off, and CP13, which is red with the yellow stripe through it there, came off. That's all I had to take off. And then loosen the screws. I pushed the board back, managed to get it over this. Be careful when you're doing it not to scratch the bottom of the board on those terminals there and damage the traces. And then I just lifted it up, and then I just changed all the components without having to try and waft it from up and down, side to side, whatever, to get the components in. I stood it up and I just unsoldered what I could, and I kept it. It was awkward, and I put the caps in while it was stood up. But it's better than keep flattening it down, lifting it up, flattening it down. You'll just break these off here, and then you've got a world of pain. You've got to scrape all of this glue off, and then you've got to remake the cables, put them in, and that's more twisting the board, and while you're doing that, more breaking off. So be very careful if you're going to do this. Obviously you take the volume controls out and the jack sockets, but that's how I got that board out. So we seem to be running nice and sweet now. I've just left it running, say, on that 60-watt bulb. So we've got, if we just look up there, we've got 229 going in DC, and we've got 144 AC, 145 near enough AC on there. We're drawing 140 milliamps off the wall. So I've checked with a meter to make sure we've got bias on the tubes as before we switched off the standby there. So I think we're good for another 100 watts of bulbs there, and you can see now the voltage is coming up. And again, we've got our, let's just put that shield on to get rid of that humming from the lights. There we go. That's all sounding pretty good. That's sounding pretty good. Let's go into the normal channel. Wow. Hands are a bit stiff at the moment. I've not played for a couple of days. Did a gig on Saturday night. And yeah, very stiff we are. A little bit distorted, but that's probably because we still got it on the current limiter. So I've got a couple of 100 watts of bulbs now. That's all looking good. Enough of that very rusty playing. If you get a bit get my hands a bit loose before I do the demo. So that's looking good. It's very quiet. So we're off the current limiter. And there we are. Right, so what I'm going to do now is I'm going to shut it down. Make sure all the nuts and bolts are tight. Solder on the leads for the pilot light lamp. I've cleaned that because the customer said it was, cleaned the terminals in it. Customer said it was intermittent. And we'll check that, and then we'll put the new tubes in and we'll bias it. But now it is lunch time, so I'm going off for lunch. And no doubt Pink will be wanting a bit of lunch too. I don't know where she is. She's kicking about somewhere. See how the bulb is all black there? And I'm not sure if there's something floated around inside that, but that's because of the overvolting of the filaments, with it being wired to 230 volts. So that bulb's had some threeps. There we go, all finished. We'll bias the tubes. Just bias them a little under 70%. Checked it on the scope, they're fine. So that's it. Got our new pilot light bulb in there. So it's all ready to go back in the case. Right, so we're just looking at this schematic now. This is there's two schematics for this amp, and this is the later one, and the amp we are working on is the later one. And you can see we've got a resistor across here, 1 ohm resistor from the cathodes to ground, and you can see here 60 millivolts. So you don't have that on the earlier models. I've not worked on this model before. I've worked on quite a few of the early ones. So 60 millivolts with a 1 ohm resistor equates to 60 milliamps, 30 milliamps per tube. Now that works out at about 16 watts, and that seems to be a running thread on some of these Fender's amps from the early 2000s. Remember, I looked at a Fender Twin with the same thing, which were biased at about 16 watts on the tubes. So remember, 70% is 21 watts. Now, when I checked, I biased this conservatively when I biased it, and I've not bothered filming that because we filmed enough of the biasing. So when I checked on that resistor, there was 80 milliamps, which was 40 milliamps a tube. Oops, sorry. So I've split the difference and put it at 70 milliamps. Now the reason they could be doing this is because the transformers aren't quite up to, you know, what they used to be, and so they don't want them overheating. That's the only thing I can think of with that. But anyway, we've split the difference on there, so we've probably got about 17 and a half watts on those tubes. Right, let's have a listen to it then. Good evening, Pink. So there we are, just a short demo there, some rusty guitar playing and some very, very painful thumbs today. Fender Bassman 59 reissue. Did quite a lot of work to this one. It's running great now. New set of output tubes, recapped it, altered the bias, upped the screen resistors to 1K, changed the preamp tube, and she's good to go. So that'll do it for this one. Thanks for watching. You all take care, and I'll see you all in the next one. Bye bye for now.